Hello Year 10. It's just a quick video this week looking at Venn diagrams, something you've already met in your live lesson, but hopefully I'll be able to elucidate some things you may not have covered in anticipation of your asynchronous work tasks for this week. And we begin with a very simple question. 40 students were surveyed, 20 have visited France, 15 have visited Spain, and 10 have visited both France and Spain. Use the information to complete the Venn diagram. Now, a very naive conception of Venn diagrams may look at that information and write 20, 15, and 10. But we notice if we add those together that we have 45 people and only 40 students were surveyed. And that's our clue, really, that something else is going on. And indeed, what's going on there is that we know that 10 have visited both France and Spain, so there are 10 there. And we know that in total, 20 have visited France. So that means this entire circle must contain 20 people. So that means 10 must have visited just France, meaning in total 20 have visited France, or France and Spain, which counts as visiting France. Similarly, 15 have visited Spain, 10 have done Spain and France, so 5 will have done just Spain. And we have one more thing to account for, which is people who haven't been to France or to Spain. If we look, we have 10, 20, 25, so 15 of the 40 students haven't visited either France or Spain. We could then be asked for various probabilities. For example, we could be asked for the probability that students had visited neither country, and that would be 15 over 40, which we could cancel down to 3 over 8. We could be asked for the probability that students have visited France, which would be 20 out of 40, or a half. Or they could ask us for some more complicated things, such as the probability that they have visited Spain, given that they have visited France. And what that means, and we would write that as the probability of visiting Spain, given that they have visited France. What that means, really, is that we know they've visited France, so we know they're one of these 20 people here. We know they're one of those 20, so it's out of 20. And we want the probability of those 20 people visiting Spain. And of those 20 people, 10 of them visited Spain, and therefore that's 1/2. So the probability of the person having visited Spain, given that they had visited France, is 10, the numbers that had done France and Spain, divided by 20, the number that had done France. Venn diagrams can also contain more than 2 different sets. So here is a Venn diagram containing sets A, B, and C. And you're asked to list the members of A intersection B. And intersection, you'll remember, means and. So in both A and B will be these numbers here. So 3, 1, and 8. Then a number is chosen at random from, and that's not printed very well, but it's the curly epsilon to mean the universal set, all of your numbers. Find the probability of B union C. So that's B or C or both. So if we look at that, look at all of our numbers that are in B or C or both, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 10 numbers that are in B or C or both. And then in total we've got those 10 and another 2, so we've got 12 numbers. So our probability is 10 out of 12, or 5/6. Sometimes you can be asked to draw those Venn diagrams. So you're given a load of information here. As soon as I see in an exam all of these different things, they like this and this and this, or they're in different sets, I'm immediately thinking Venn diagram. Sammy asked 60 people which sports they liked from rugby, football and cricket. 8 people like all 3 sports, 17 like rugby and football, 13 football and cricket, and we go on. How many people liked neither rugby or football or cricket? Now, I guess it's theoretically possible you could do this in your head, but I would not recommend it. As I say, this is screaming out Venn diagram, so I begin by drawing my universal set, and then I've got rugby, football and cricket, so I'm going to draw these 3. And I'm never very good at making these big enough, but that's not too bad. Rugby, football, cricket. And then I'm going to start filling them in. 8 people like all 3 sports. 17 like rugby and football. So in this area here in total there must be 17. So we've got 8 that like all 3. So we must have 17 subtract 8. We must have 9 that like just rugby and football, because that means 17 like rugby and football in total. 13 like football and cricket, same idea here. This total intersection must be 13, so 5 like just football and cricket, and 8 like all 3. And then 19 like rugby and cricket. Once again, same idea. We have 11 that like just rugby and cricket, plus another 8 that like all 3. And it's probably sensible to tick these off as we go. 35 people like football, so everything in this circle must be 35. So I could do that in my head, but let's imagine I cannot. I know that that total circle should be 35, and I've already got 9, and then 8, and then 5, so 13 people only like football. So the total number of people that like football are 13 plus 9 plus 8 plus 5, 35 people. Similarly here, 27 like cricket. So I'm doing 27, subtract 11, subtract 8, subtract 5, to give me 3 people that just like cricket. And then finally 30 people like rugby, so 30 in total. I've already got 11 and 8 and 9 in these 3 boxes here, leaving me with just 2 who only like rugby. Now the question wasn't that. The question was how many liked neither rugby or football or cricket. We want this number out here, effectively. But we know that 60 people in total were asked, so we just use our idea here again. 60 in total were asked. Of those, 2 only liked rugby, 9 liked rugby and football, 8 liked all 3, 11 liked rugby and cricket, and then 13 liked just football, 5 liked football and cricket, and 3 liked cricket. You'll notice I've been very careful to only count each of those numbers once, leaving me with 9. Some of you may have spotted an easier way to do this as well in this case, using the information you have here, but it's quite easy to make mistakes doing that. So I'd recommend always drawing your Venn diagram. How many people liked neither rugby or football or cricket is 9. If you were asked instead for a probability, I remember we write that as the probability, not rugby, not football, not cricket. So we want not rugby and not football and not cricket would be 9 out of 60. We've got a common factor there of 3, so 3 out of 20. But that's not what the question asked you here. The question just asked you for 9. And hopefully that's elucidated some of these approaches a little bit more clearly.